This is the core retake practice for Unit 2. For questions 1 through 3, state the transformations and the end behavior of the function. So if you're unsure about some of these things, you can use your calculator to help, but you should be able to get it straight from the equations. The transformations, the 2/3 that is in the front of the absolute value represents a vertical shrink of 2/3. If the a value is less than 1, it's going to be a vertical shrink. If the a value is greater than 1, it's going to be a vertical stretch. The -4 represents a shift to the right 4 units, and the +1 represents a shift up 1 unit. This function has no reflection, so it is our normal V shape that is opening up. So the end behavior for this function, on both the left side and the right side, they will both approach positive infinity. Number 2, I have a vertical stretch of 7. I'm going to the left 2 units and down 3 units. This one again has no reflection, so it's going to be the V shape opening up, which means that our end behavior will both go to positive infinity. On number 3, the a value is -2. The 2 is going to be a vertical stretch of 2 because that's greater than 1. The negative is a reflection over the x-axis. You have to look at those two pieces independently in terms of transformations. X plus 3 means that we're going to the left 3, plus 5 is a shift up 5. Since there's a reflection over the x-axis, that means that our V shape is now opening down, so our end behavior will go to negative infinity on both sides. For questions 4 and 5, write an equation in the form of y equals a times the absolute value of x minus h plus k that goes through the given vertex and the point. The vertex gives us h and k, and we can use the extra point as an x and a y value to plug in to solve for a. So in number 4, I'm going to label the hk, x, and y. And then we're going to use the formula it gives us and plug values in. So my y is 9. A, I don't know. X is -2. H is 2. And K is 1. So now we just need to use order of operations to solve for A. So we'll subtract 1 first. We can also go ahead and do -2 minus 2, which is -4. Now the absolute value of -4 is a +4. So I've got 4 times A equals 8. And then I need to divide both sides by 4. And I get that A is equal to 2. So the equation, I'm always going to plug in the a, the h, and the k, not x and y, to give the final equation. So y equals 2 times the absolute value of x minus 2 plus 1. Number 5, again, I'm going to start by labeling the h, the k, the x, and the y, just to make sure I plug things in correctly. My y equals a times the absolute value of 5 minus negative 1 plus 5. So we subtract 5 from both sides. Minus and negative becomes plus, so 5 plus 1 is 6. The absolute value of 6 is 6. So I have 6 times a equals negative 4. When we divide by 6, this fraction reduces to negative 2/3 as our a value. If you don't remember how to reduce fractions, you can put negative 4 divided by 6 in your calculator, and math enter will reduce the fraction for you. So we get y equals negative 2/3 times x plus 1, because the minus negative becomes a plus, plus 5. For questions 6 through 8, write the equation or the inequality for the provided graphs. So we're going to use the vertex to determine what our equation should be. So looking at number 6, my vertex is at 1, negative 5. So that gives me my h and my k. The slope here is 1. So there's no a value. This is not an inequality because there's no shading. So I'm going to write the equation y equals the absolute value of x minus h would be minus 1 plus k would be minus 5. Number 7. The vertex is at negative 1, positive 1. So again, that's my h and my k. There is a reflection because it's opening down. So when I start to write this, I know that I have to have a negative. X minus negative 1 becomes a plus 1, and then plus 1 for my k. Now this one is an inequality because it's got the dotted line and the shading. Since we're shading above, it's going to be a greater than. And since it's a dotted line, I do not include the underline. Now for number 8, again starting with the vertex, I'm going right 2, up 4, so that's my h and k. There's no reflection, so I've got x minus 2 inside the absolute value, plus 4. This one is also shaded above, so that's going to be greater than. But because it's a solid line, it will be or equals to. On the back, number 9, what are the steps to solve an absolute value equation or inequality? First step is always to isolate the absolute value. We cannot do anything algebraically until that absolute value is by itself on one side of the equation. Step 2, at this point, when the absolute value is already isolated, you have to check for negatives on the other side. Once we're assured there's no negative number, then we split the absolute value into 2 separate equations. One is the positive version, one is the negative version. Number 4, step 4 is to solve as usual. And number 5 is to check our answers. Specifically, when there's an x outside the absolute value, that's when we need to check for extraneous solutions. So let's look at these last 6 problems that are solving. So number 10, we're going to start by isolating. So I'm going to add 8 to both sides. I get the absolute value of 3x plus 2 equals 11. I check to make sure that's not negative. To get rid of the absolute value symbols, I have to split it into 2 separate cases. I've got 3x plus 2 could equal positive 11, or 3x plus 2 could equal negative 11. Now I solve normal. And those are my 2 solutions. Number 11, same idea. We've got to isolate the absolute value first. So I start by subtracting 3 from both sides. And then we divide the coefficient. Here I check for negatives. Since that -1 is there, I know there can be no solution because an absolute value has to yield a positive result. Number 12, start by dividing by 4 to isolate the absolute value. The 4 is not negative, so we're going to split this. X plus 5 could equal positive 4, or x plus 5 could equal negative 4. So x could equal -1, or x could equal -9. Number 13, this is an inequality. We follow basically the same steps. The absolute value is isolated. The 3 is not negative. So since this is greater than, I'm going to use an OR statement. So to split this up, I'll have x minus 4 is greater than 3. So the first one is always identical to the starting problem without the absolute value symbols. The second one, when we put the -3, we have to flip the inequality symbol, just like we would if we multiplied or divided by a negative. Then we solve these as normal. So x is greater than 7 or x is less than 1. Number 14, start by isolating. So we're going to subtract 5 first. I get -3, absolute value of x plus 1 is greater than or equal to -3. And then I need to divide the coefficient. So I get the absolute value of x plus 1, and because I divided by a negative number, I have to flip the inequality, and I have a +1. So this step right here is where we want to check for negatives, and where we decide if it's going to be and or. So since this is less than, it's going to be an and statement, which we can write as a compound inequality. So the x plus 1 comes out of the absolute value. The +1 goes on the right, the -1 goes on the left, and we keep less than or equal to symbols. Now to finish solving this, I just need to keep all 3 pieces balanced. So I subtract 1 from all 3 sections, and I get -2 is less than or equal to x is less than or equal to 0. And that is the solution. On number 15, we will start by adding 7. And then we divide the coefficient. Five is not negative, and this is less than, so it's going to be an and statement. So the x plus 6 comes out of the absolute value. I have 5 and -5. Both symbols are less than. And then I finish solving. And I get -11 is less than x is less than -1.